Good morning, everyone. Thank you so much for having me. I'm super excited to be here. How many of you have been at Serverless London last year? A couple of hands up. I just want to point out one thing. In London, we had this conference in a church, and now we're in a pub. I think we have to adjust things, and okay, cool. So I hope you're absolutely excited about building APIs using Serverless and GraphQL. And we're going to have Gosh. Is that the correct pronunciation? Anyone? Goch. A kind of keep us company along this journey of discovering how Serverless and GraphQL, what do they have in common and how do they work together? So one of the first things is that both of them are right now on the hype train. What does that mean? Basically, it means that every single day, probably there's a community, a library developed by the community out there and is being published probably right now as I'm speaking. Both GraphQL and Serverless are, if we look at this tweet by Nader Dabit, when he looks at 2019, not 9, he says that Serverless will definitely continue to explode, become more and more popular. Developers will continue to build third-party APIs and services that we can use as they are without reinventing the wheel. And definitely, GraphQL will continue to gain market share. So both technologies are going to continue to grow in this year, and I highly recommend all of you look into them. Another thing that they do have in common is that they appeal to JavaScript developers. How many of you are JavaScript developers here, or how many of you write JavaScript code? That's probably half the room, hopefully. And one of the reasons why, for example, Serverless is absolutely great for front-end developers and JavaScript developers is that as we're building our front-ends and the client applications, we can actually, with Serverless, we are empowered to build backends for our applications as well. And what GraphQL empowers us to do as client developers is basically define the data that we want to retrieve from our APIs. And that's very important because that means that we no longer are blocked by what the API developer is doing. We have access to all the data, we just need to query it. And we can continue our development. Another thing that they have in common is a timeline. Serverless, Lambda, as we all know, probably came or was published around the end of 2014, and GraphQL has been open sourced in 2015. The specification and the GraphQL JavaScript package have been published in 2015, even though the development started much earlier. And there's another magical thing that we're going to discover throughout this talk about what these two have in common. And let's start with GraphQL. Does everyone love this animation? Yeah? We're going to have a couple of them. So when GraphQL came to be at Facebook, basically the team was rewriting their mobile application. And as they were looking at their APIs, they realized that they need to build something new. And what they really wanted to build was a data fetching API powerful enough to describe all of Facebook. And I'll let that sink in. All of Facebook. So if I'm looking at my timeline here, we can see that right here on your left-hand side, we are retrieving data related to my particular user. Things like a link to Messenger, the events that I've been invited to, maybe some of the groups that I belong to. In the middle of the page, that's posts for those of you that don't use Facebook. Those are posts that my friends are creating. And then on the right-hand side, it's things that are related to my user as well, like friends' birthdays and friend suggestions. So from a REST perspective, if we were to think what kind of requests we have to make to retrieve all of that data, probably these are some of them. I think there's a legend that says that probably Facebook made a couple of hundreds of requests back in the day to retrieve all this data that is being displayed to us. And then if we look in particular at events, how would we retrieve a list of events and what kind of data would be returned to us? It would look probably something like this. Even more information, so a JSON object with lots of information. But what we really need to display this page is actually just the number of events. So in this case, we're displaying that I've been invited to 4 events. So what does that mean? It means that whenever we're retrieving data from REST APIs, we either overfetch, so we request more data than we actually need, or we would have to either create a new endpoint that would return the number of events, and probably nobody's going to do that, so probably we're going to have to update an existing endpoint that returns that data with just the number. Why isn't this ideal? Well, overfetching means that we are basically spending more data, especially in the case where we're using a phone, we are spending user data to send data that's not needed, or we would have to synchronize with those backend or with the backend team in order to update the API to include a new field. So that was one use case. The other use case, if we look at this page on the right-hand side where I'm being suggested to become friends with Golnaz, basically the information that I have there is a profile picture, her name, and the number of mutual friends. So again, thinking in REST terms, we would probably make a request to retrieve the list of friend suggestions, and we would get an array of people with their names, their profile picture, a list of mutual friends, and then would have to make a new request to get the list of mutual friends. So this is known as the N+1 problem, where basically we make a request only to discover that we need to make another request. And that means N+1 round trips to the server. So this pattern is known as underfetching data, which means that we are retrieving less data than we actually need to display. You can find it not only in REST APIs, but also in databases and probably a couple other places. So our options are either underfetching data and making more requests than are actually needed to the server, or adding or updating a new endpoint. And we already know that that's not ideal because there's some synchronization there. Imagine in a very enterprise environment, you'd have to create a new task, you'd have to discuss that with your product owner, you'd have to make sure that it's agreed on, specify it, add tests. So that's a lot of work. Why do we care about all of this? Well, if you think of, especially of client performance, and how this data is being displayed to the user, basically either making those round trips to the server or retrieving more data than is needed, it actually affects the data and the pages that are being displayed to the user, either on a phone or on their browser on their desktop. As we can see here, this is a table that I've copied from a very good book that I highly recommend, High Performance Browser Networking. If you're interested in learning about that, basically what it says is that users are going to perceive our website as working anywhere between 300 milliseconds and a second. Whenever the performance or our website takes longer than a second to execute a task, they're just going to context switch. They're going to do something else. And if it takes longer than 10 seconds, they're going to say, I'm never coming back. Thank you. So it's really important to be mindful of the user performance and the data that we're sending down the wire, as that will drive users away from our website. The fastest network request is a request not made. So keep that in mind. It's a quote from the book that we've seen earlier by Ilya Grigorik. So why am I saying that? Because as probably some of you know that you've worked with GraphQL, basically when we're making requests with GraphQL, we only need to send a single request. And in that request, we have to request the data that we want to display on that page. And that's pretty much everything. We don't have the n+1 problem anymore. So this is how a query would look like. Where we're requesting data for the user with a certain ID, we can filter for ID, and then we are listing the fields that we want to display. So in this case, name, events, maybe here we can say that we only want to retrieve the count of events, and that's okay if that already exists on the back end. And then the response will be a JSON object that will mirror the exact same request that we made. And that's fantastic news, because that tells us again, and it validates the fact that our backend or our API will return exactly the data that we have asked for. So whenever we get started with GraphQL, we basically bring all the teams together that are either going to create the APIs or consume them, and have them define a contract. Have them define the operations that they want to execute in order to display data, and define this thing that's called a schema. So contract, where we define the operations. And this schema contains a series of types, so that will describe the objects that we can retrieve. And this is how you define one. So you basically use the type keyword. In this case, we are defining type people that has a couple of fields, and then you can see that we can assign an ID, and that's a scalar type. That's like a primitive type. We also have the string type, and we can define custom scalar types, in this case URL. Think of date formatting. That's something that you'd want to implement in your application, and that would be a custom scalar type. We also have nested types. There's support for nested types. In this case, our team contains an array of people. And this is how you define arrays. You use square brackets to say that this will return an array of people. And then there's other two types that are really important. The first one is query. This is a root type, and basically what it says is that with query types, we are able to retrieve data. With query operations, we can read data, and with mutation types, we can either create, update, or delete data. So imagine query is your usual get operation, and then mutation is your post operation. And this is where we say that we can read all the teams, and what we'll return is an array of teams. And then with increment points, we're actually going to increment those points and return an object of type team. But we're going to filter by ID, and the exclamation mark says that this field is mandatory. But that was the schema, and that was a representation of the operations that we have available and the types that are describing those operations. But we actually have to go to the work and retrieve the data, and we do that through a thing called resolvers. And this is where we can either call an existing API to retrieve all that data, or we can actually go ahead and query a database. So in this case, you can see that I'm calling two existing endpoints. Those are two functions that are available in the cloud, and I'm returning that data. Another really cool thing about GraphQL is the tools that we have available. And one of them is called Graphical. And we have access to real-time documentation right here in this UI, where we can inspect the operations that are available for us, as well as the types and the objects that are being returned. What Graphical allows us to do as well is execute those queries. Imagine like anything like a SQL or a database client where you can inspect your tables, and you can query those tables, execute, and see the result. This is exactly what you can do with GraphQL as well. And it also gives us error. It tells us if we're trying to execute operations that don't exist or access fields that don't exist on those types. It does even suggest what kind of operations we might want to use. So what does GraphQL help us with? Well, it helps us build more performant applications. It also helps us build more flexible UIs. We have the power of requesting exactly the data that we need, and that's pretty valuable. And we have powerful tooling. We've only seen GraphQL, but Ant here is also building another tool for building applications with serverless and GraphQL. And there's a couple other tools that are available for us. The community is building a lot of them. Okay, so what about serverless? We've seen a lot of talks about serverless. Clearly, we're all in this room because we either want to learn more about serverless or because we're already building applications with serverless. So probably I'm going to go very quickly through this chapter. But this is a quote that I really love. The line of code that's the fastest to write, that never breaks, that doesn't need maintenance, is the line that you never had to write. And this is what serverless enables us to do, right? It enables us to, instead of having to reinvent the wheel and write a lot of the services that don't bring value to our business, it enables us to reuse those APIs or services, as well as we don't have to write configuration code, a lot of it. This is how a hello world in Azure functions look like. I work for Microsoft, so what we're going to look at today is Azure functions. This is JavaScript, where basically we have a function that gets two parameters, a context object, which will enable us to talk to the Azure functions runtime, and the request object. And then we can set the response on this context object. This one of the powerful things about Azure Functions is that whenever we're using it with VS Code and the Azure Functions extension, is that we can actually run that function in our local, and we can also debug it. As Dean mentioned, Azure Functions is open source, which means that the runtime that we're running in our local is the same as the one that runs in the cloud, and it enables us to debug applications locally. We can right-click deploy. But we don't want to do that, right? A friend of mine always says, friends don't let other friends right-click deploy. I wouldn't want to override Dean's work. But you can do that using VS Code. If you're working on your own project at your own risk, you can actually right-click deploy, and this will zip up all your code and push it to the cloud. But a better version is using GitHub to deploy. So basically listen to changes that we push to GitHub and then make sure that we deploy that using even maybe a CI/CD tool like Azure Pipelines or Circle CI, whichever is your favorite. But I think that the power of serverless also comes from the way we integrate with third-party APIs and the way we can read from data sources. So I know that Azure has a really easy way to integrate with things like Azure Cosmos DB, which would be the equivalent of DynamoDB. And then there's a couple other things that we can read from, things like blob storage or table storage. We can even read from an Excel file. And this is how you would configure this using the portal, the browser. And then in the JSON, the actual declarative way of saying that we want to read data from Cosmos DB is these 6 lines of code. And then when using this in the actual function, we only have to access that binding that we just defined there. So context.bindings.input document, this will actually read from the database directly. So why is serverless great? Well, because it allows us to build reusable APIs. We can use tooling that we've already we're already using and we love. And it also allows us to build easy integration with data sources. And there's no servers to manage, which is great. So what about GraphQL and serverless? How do we get started with both of them? And why would we do that? If we look at the way we normally build applications, or we used to build applications before serverless existed, we either had a monolith application or a microservice somewhere. And as we discovered serverless, we started migrating some of those functions or some of that functionality, but very shyly, right? A couple of services there. And then as we got more and more excited about serverless, we implemented more and more functions. And a lot of our code now looks like this. This is actually not a very accurate diagram, but Jan and Jillian have showed us some very complex diagrams where you have tons of code that is spread all over the place. So I think that's where GraphQL actually helps us with when it comes to serverless, because it gives us that real-time documentation where we can inspect into our API. So we can inspect into our existing endpoints and kind of bring them through a single endpoint there, through a single interface. And we can see that right there. So when it comes to how do we implement GraphQL using Azure Functions, well, basically we use the GraphQL JavaScript package, which was one of the very first packages that has been released. And then we initialize that using the schema that we've defined and the resolvers that we've just seen, and we pass in the query. And that's everything. This is how we expose GraphQL through an Azure function. So looking back at what we've just seen, we have our browsers that can query into a GraphQL endpoint, which sits on top of our in our Azure function, and then that queries into two different existing Azure functions. And that's a very common use case for GraphQL, where instead of rewriting an application, we actually keep that API and we put GraphQL as a thin layer on top of our existing API. Another use case is where if we're building new functionality, we can go ahead and actually query directly that database. Or, even better, we actually read from an existing cache, which will make our application even faster. And in fact, GraphQL makes even a lot more sense when instead of having a single client for our API, we actually have different types of clients. So reading data from a browser, from a mobile application, and then accessing the GraphQL endpoint. So why GraphQL and serverless? Serverless, on one hand, gives us easy integration of data sources, and GraphQL gives us easy abstraction of data sources. So with GraphQL, we can abstract away existing APIs, databases, caches. We can read into those data sources, but what we really expose is one endpoint, and the client doesn't really care where we read that data from. Serverless gives us auto-scalability, and GraphQL exposes a single endpoint. So imagine when we bring them together, we have that single endpoint that can auto-scale infinitely. With serverless, we write less code, and with GraphQL, we make a smaller number of requests, as we've already seen. So what these two have in common is that they bring larger developer productivity, bigger developer productivity. They enable us to build performant applications without writing a lot of code and without wasting time on network data and round-trip requests. So basically, we can achieve more by doing less. This is a workshop that I've published on GitHub. If you want to learn more about serverless and GraphQL and how to integrate both, make sure to check it out. And I think that's all. Thank you.